Hello everyone, good morning. My name is László Szabó, I'm director of REC, and I would like to welcome everyone on this nice workshop organized by the Regional Center for Energy Policy Research, REC, in Hungary. And I would like to welcome all of our guests, the presenters as well, the panelists, and all the participants in the meeting. Due to some schedule changes, what I will do is that I will do a very short introduction, and then I will give the floor to the first speaker, Diana Ürge-Borsac. So I really shortly would like to just emphasize maybe few things. One of the most important IPCC working group report, the third one on mitigation, just released in April of 4th, which is an enormous work. It's really a work of years, and actually quite many authors, a few hundred authors, are putting together all the information available for the IPCC reports. And it's really a report which is, I would call it a very heavy one. Heavy in that sense, it's a lot of work. It is really building up a consensus on what is going on in this field of climate mitigation field. So it's a report which we'll have to spend a lot of time to really read through and understand the messages of this report. And we are really lucky to have 3 of the authors here. And I don't want to really spend too much time because I know that Diana will have to leave very soon. So I don't want to take the time for her. So I think the best solution is to give the floor straight to her, and then we'll hear the important messages what we can hear from her, because we should know that Diana is actually a vice chair of the IPCC Working Group 3, so she is actually quite in the coordinating of the work of this report. And besides this coordination work, she is a professor of the Central European University. At the same time, she has many other things to do. So she is served as a United Nations scientific expert group as well. So quite a very important position. She's dealing with energy efficiency related issue, editor of the Journal of Energy Efficiency as well. And then you are advisory board member of many institutes and many companies there at the same time. You are producing reports, not only the assessment reports, but scientific reports as well in many journals. So we are really looking forward to your contribution. And actually what Diana will cover in these 20 minutes, what she has, actually that she will give a focus on the climate science context actually of the report. And then after that, it will be followed by 2 additional presentations by Michael Group and Goran Strabac. But first, the floor is Diana. So please go ahead with your contribution. And we are really open to any question which you can write to us, and then we'll try to answer it later when we go to the panel session and the question and answer session as well. So thanks a lot for joining us, and the floor is yours, Diana.
Thank you very much, László. Now, I thought I'm very good after the pandemic with every single platform, but I'm not sure if I'm showing my screen now or how to show my screen. Can you see my screen now?
Now we see it. Yes. Perfectly see it.
Then I just have to somehow because I don't see my screen from the panel. In any case, let me try to. Okay, let's hope that if you can see it, that's great. And shout if you can. Okay, very good. So yes, indeed, first of all, thank you very much for the invitation. And indeed, I have to be a bit fast because actually we are in the middle of the meeting of the synthesis report of the IPCC, and I am leading some of the processes, so I have to rush back for those. And yes, I will start with the climate science as well, but my understanding was also that I will also present some of the aspects of the Working Group 3 report which are not going to present it by the next two speakers. But anyway, let's see. I hope that I'm not going to be stepping on anybody's toes, and you are going to enjoy, or you're going to benefit from what I'm presenting. So first of all, as you know, the IPCC is is working in terms of assessment reports, which are published every 7 years and which synthesize the science and assess the science over the last 7 years. And this is done by assessing at the end of the day, hundreds of thousands of publications, but each working report is actually concretely summarizing tens of thousands of scientific journal articles and publications by hundreds of authors. And we have 3 volumes, one on the physical science basis, one on impact and adaptation, and one on mitigation. So I'm trying to kind of give a merger of this. The first of this series of the 6th assessment report was published in August, and it was coined by Antonio Guterres, the UN Secretary General, as the Code Red for Humanity. And yes, indeed, the report showed that recent changes in the climate system are widespread, rapid, and intensifying, and unprecedented for thousands of years. And in fact, not only actually, I think thousands of years is almost an optimistic statement for me, because if you look at the numbers from the report, it actually shows that global average temperature has not been so high for at least 125,000 years. So we have already turned back the geological clock of the planet by over 100,000 years, and this happened only in less than a generation. We have already, and this is only as a result of just 1 single degree, because we have only warmed the climate by 1.1 centigrade as compared to the pre-industrial average. Global carbon dioxide concentrations and also the global surface acidity has not been so bad for 2 million years. So actually, from some perspective, we have already rewound the geological clock by 2 million years. In terms of methane and nitrous oxide concentrations, they're higher than any time in the last 800,000 years. And unfortunately, what the report shows, that there is no going back from some changes in the climate system. So some of these changes are already irreversible, even if we don't emit a single molecule of carbon dioxide or greenhouse gas anymore from tomorrow, which is clearly is impossible. But even if you assume we don't, many things would still, many of the changes that are caused by humans will still be continuing for hundreds or even thousands of years more. For example, global ocean temperature will keep increasing. The Greenland ice sheet and many of the ice sheets, for example, European glaciers, will keep melting for thousands of years more. The sea level will keep rising also for hundreds and thousands of years. But perhaps what was a bit scariest for me is about what we often call the tipping points. But this report refers to these, and these are not quite all the same, but this is the high-level categories, the low likelihood, high impact outcomes, as well as tipping points. And here I just put a couple from the report. So loss of the Greenland ice sheet, which alone will translate into about 7 meters of sea level rise. The collapse of the West Antarctic ice sheet will also result, just alone that will result in several meters of sea level rise. The abrupt collapse of the Atlantic meridional overturning circulation, of which the Gulf Stream is part, and of which which very significantly determines Europe's climate, also our climate. But what was even sadder for me is seeing the forest dieback. We heard a lot about Amazon dieback and the permafrost, but we hear much less about that. Actually, forests are one of the big losers of climate change already. So we heard much about the coral reefs and ice sheets. But facing the fact that already forests are significantly dying all over the world, and these are one of the big impacts that already have badly happened, that was very sad to face. And this picture is actually, I took it from the Tato Mountains in one of my recent trips. And if you've been there, you see that there is this, virtually all of the pine forest in the Tato Mountains have died back. Yes, partially from storms, which are also, these very big storms are aggravated by climate change, but also by different pests and diseases. But you don't have to go as far as the Tatra Mountains, because also in Hungary, if you go to the Buk Mountains and so on, many of the forests already had to be cut out. And for example, Lutzfenyő type of pines don't grow anymore in Hungary, which used to be one of the most typical forests. But it's a problem because actually forest and nature is one which would actually help us protect ourselves against climate change significantly, and this is so we are here preventing one of the important defense mechanisms against exactly climate change. The problem is that many of these tipping points actually are started probably between 2 and 3 degrees climate change. Of course, there are big uncertainties. There is already some publications which suggest we may already seeing signs of the collapse of the AMOC. But anyway, so these are not far away. Unfortunately, the 2 to 3 degrees, according to, you will see in one of the next slides, that we may reach 2 degrees as soon as the middle of the century. And then you already may have committed, or very soon. So really, it's very much in our lifetimes, still not even in our children's lifetimes, that we may already commit the climate system to these very major irreversible changes, which will have very significant impact on us, which we may not even be completely aware of, because it has never happened in civilization's history. So that was the bad part. The good news is that some changes can still be slowed and others can still be stopped by limiting warming. And this is the so-called burning embers diagram that the IPCC does. Let me walk through for virtually all of its assessment reports, and let me just quickly walk you through. So this is historic temperature, and we see that we already, this very stable temperature, which has been stable throughout the civilization's history, we have already increased by slightly over 1 degree centigrade. And what the point is that even if we know that we are virtually certainly reaching 1.5 degrees already by the end of this decade, actually, approximately, it's really a very different future that if we are able to stabilize the temperatures at that level, or we keep growing the temperatures, and towards the end of the century, we may reach as almost as high as 5 degrees. And this does not yet include any of the scenarios where there is some low likelihood events trigger bigger climate change. So there is definitely very different futures. So we still have a major opportunity to prevent much of the impact. And what these figures show, and don't necessarily look at actually what are these different impacts, but what we do in the so-called burning embers diagram is to show that as a function of temperature increase, how bad will the impact be in different systems. And these are the different systems which are picked as some of the main systems to illustrate that or summarize the types of impacts. But we do that for many kinds of impacts. Here, the white is where we don't detect the impact. In yellow, the impacts are already quite bad. When the impacts are red, it's already really very severe. We experiencing impacts, and when they are purple, we are mostly not able to adapt anymore. So much of the purple is where we already reached the adaptation limit. And the sad news is that actually the more assessment reports we do, these colors are keep coming down. In fact, purple, if I remember well, didn't even feature in earlier assessment report or in much earlier assessment reports. And if you compare it to the 5th assessment reports, all these colors, the bad colors, have significantly come down. So the more we know about climate science and climate related sciences, the more we understand that actually the impacts are going to be much worse. So we already see that already at 1 degrees, we are already in the red zone, for example, for unique and threatened systems such as coral reefs, and that this is why why 1.5 degrees would be really quite important to keep, because already at 2 degrees we face much more systems where the impacts are irreversible, and where you cannot actually adapt. So of course, the big question is, okay, but can we still get to 1.5 degrees? So what we unequivocally say that unless there are immediate, rapid, and large-scale reductions across all in greenhouse gas emissions across all sectors, limiting warming to 1.5 degrees will be beyond reach. So that means that it's not. We really need very significant efforts, and our latest report, and probably Michael will show that basically we have only 3 years left. We have until the end of 2025 to turn around the trend in emissions, and if we don't peak the emissions by 2025 and start to keep reducing it afterwards, that boat will be gone. And another important statement of the report is that limiting human-induced global warming to basically any specific level requires reaching at least net zero carbon dioxide emissions, along with strong reductions in other gases as well. So that's why we have now much more emphasis also on methane, but still it doesn't mean that we don't have to have a net zero CO2 emissions. So that means that even if we let the 1.5 degree boat gone, even if we let the 2 degree boat gone, even if we let the 3, 4, 5, 6, 7, 8, 9 degree boat gone, even if we stabilize the temperature 10 degrees warmer, we still have to reach net zero CO2 emissions. So that means practically that we have to give up fossil fuel use, well, actually how our report says unabated fossil fuel use, but there is, the capacity for abatement, perhaps the other colleagues can discuss that. So that means that the sooner we do this, the sooner we can, the lower the overall, the stabilization temperature will be. So coming back to how this can be done, and that is in the Working Group 3 report already, the good news is there are many options available now in all sectors that can at least halve emissions by 2030. So it's really, it's all in our hands. And one of the big innovations of this report is that we have a whole chapter on demand and services, and that features very high in our whole assessment, that it's not only about how you can produce the next kilowatt hour of electricity or next kilojoule of energy in a way that mitigates climate change, but also first think about how not to have to produce that 1 kilowatt hour and then energy. And that's if you put more emphasis on the demand and demand reduction and how you supply services, what people need, then actually you will be more flexible on your supply side, how you meet the mitigation challenge. So what we show that actually you have up to 70% of potential to bring down global emissions by 2050 through individual changes to societal, socioeconomic, cultural changes. But it's very important that that this can be only that high if these are enabled by systemic changes. So if these systemic changes are now there just only by individual action, the potential is significantly lower. So we could have some immediate reduction of 5% if just by individual actions. But if these are enabled by systemic transitions, such as safe bicycling and walking infrastructures, such as cities where which I will show, where the jobs and living places, so jobs and homes and educational facilities and so on are co-located, so that you don't have to get into your car and travel every day and commute every day and so on. So such systemic transitions can enable these large emission reductions. This chapter found that the largest such reduction could come from switching to walking and cycling, so switching to active transport, electrified mobility, reducing air travel, and building related energy efficiency and demand side reductions, or even sufficiency. So this is the first report that actually even mentioned sufficiency as one of the mitigation opportunities. Lifestyle changes require systemic changes across all of society, as I mentioned, and we acknowledge that some people still require the increase of service levels, and that's very much the case of Hungary, that this huge disproportionality, while the rich is responsible now. Actually, our report says that the richest 10% is responsible for 43% of global emissions. The poorest population segments are much less responsible, and they still need to increase service levels, while the rich have a major agency to reduce their emissions as role models, as investors, as consumers, and as citizens. So in transport, as we mentioned already, it is the very important, among the most important aspects is actually reducing demand. And now you see that also in the summary for policymakers, virtually all sections start with even in that sector, every sector, in order to really reach net zero, one of the most important things we have to do, or you have to start with, is reducing demand. And then supply the remaining part by low carbon technologies. The electric vehicles have certainly the greatest potential, as I mentioned. Battery technologies have major advances, and this will be shown, I guess, by Michael or Goran. In aviation and shipping, you have to look at alternative fuels, but even those won't fully reach to net zero. So very important is how to decarbonize the power sector and reduce demand, so that you can, and the remaining emissions, you will likely have to apply carbon dioxide removal methods, but these three have to go together in the transport sector. In cities, as I mentioned before, it's very important to design the cities differently. So have this 15-minute cities, so co-locate the jobs and everything else that we have to do, so that we don't have to travel, which will result in less lanes, less cars, less embodied emissions, therefore in the infrastructure. And when you have less of these, you are able to integrate more of the green infrastructure back, so more parks back. And yes, we do say that the carbon uptake and storage, even in the cities, is important. So more green spaces, more parks, more blue infrastructure, so more ponds and so on. And also here, electrification is among the most important strategies, as well as sustainable production and consumption of goods and services. For buildings, it is possible to reach net zero emissions in 2050 because by today we know how to build and retrofit buildings to be net zero energy. And I already was fortunate to present some of my papers on this, and the chapter has very much built on this paper, so you may know this already about this. And but this does require ambitious policy packages, because for retrofitting this is not easy, certainly. Action in this decade is critical to fully capture this potential because of the large lock-in risk in this sector. In industry sector, also the industry sector also starts by the demand, so using materials more efficiency, reusing, recycling, minimizing waste, repurposing, for example, repurposing buildings, repurposing materials. increasing the durability of products and goods and infrastructure. These are all very important strategies in the industry sector. These are underused in both policies and practices, and I might say this is just added by me, and scenarios. We never really consider these opportunities in all of our scenarios either. There are advances in basic materials, but many of these new processes are at pilot to near commercial stage, but still achieving net zero is challenging and most likely will require some carbon dioxide removal. And land can provide large-scale emissions reductions and remove and store carbon dioxide at scale, and many of these have to rely on restoring and protecting natural ecosystems, especially forests as well, but peatlands, savannas and grasslands, which are actually also important in Hungary, and not necessarily looking, we always thought about new forests. No, restoring rather than natural systems is what the report focuses on. But it also emphasizes that land cannot compensate for delayed emission reductions in other sectors, because land also has its limitations of how much it can do. And so, as I mentioned, there is a strong emphasis also on carbon dioxide removal, that it's required to counterbalance hard to eliminate emissions, mostly through biological methods, even though there are also new technologies, but they still require more research, upfront investment, proof of concept at larger scales, but they will be essential to achieve net zero, as I mentioned already, but also methods for monitoring, measuring, reporting and verification will be essential. And since I'm not presenting energy, but I thought I just want to point out a couple of points which don't always get mentioned, and because I think these are very relevant for Hungary and Hungarian energy planning. So just, and this will be my last point. So first of all, the report says straight that actually maintaining conventional emissions-intensive energy systems is now in many cases more expensive than switching to the low emissions ones. Still, fossil fuels are still subsidized by approximately 6.5% of global GDP. So that's just my addition. So instead of making them pay a carbon price, in fact, we are subsidizing them by each ton of CO2 emissions by a very significant degree. So that was only my addition. But the report goes on to say that electricity systems powered predominantly by intermittent renewables, but also through intermittent renewables, are becoming increasingly viable. I know there is a lot of skepticism in Hungary about this, but this report shows that actually electricity systems in some countries and regions are already predominantly powered by renewables. And recognizing that, yes, powering the entire electricity system is challenging, but so there are operational, technological, economic, regulatory, and social challenges for powering the entire electricity system or energy system by renewables only, especially by intermittent renewables. A variety of systemic solutions exist to accommodate large shares of renewables in the energy systems have emerged, and there are many of these opportunities detailed in the report. So to conclude, what we can say is that that our future will be determined by a composite of how much we can reduce emissions. What we couldn't reduce, we have to try to adapt to. What we can't even adapt to will remain as suffering. And the second working group report very clearly shows that there are really limits to adaptation. And actually, we are going to reach many of these hard limits. For example, in Southern Europe already at 3 degrees, where water is simply going to be not sufficient to do all what we are doing today. And there's no way to produce or bring there enough water for, let's say, irrigation. So there will be a lot of suffering left unless we change course significantly. Today, we can still determine which mix of these 3 will comprise our future. And the good news is that in terms of how we mitigate, we can still choose. We still have a lot of choices. But we will have no choices in how we suffer the impacts of climate change if we fail to mitigate thoroughly. So really, our future climate depends on our actions today and our choices today. And I hope you will all, and you all have very important roles, because you are determining our choices, for example, in the energy sector, and that's really cardinal for being able to have a more livable climate. Thank you very much, and I will be happy to help with how you find the report. And I wish you a successful rest of the conference. Unfortunately, I cannot stay for the discussion. I apologize for that. Thank you.
Thank you very much, Diana, for your very interesting presentation. And we are sorry as well that you have to leave, but we understand that the IPCC work is really an ongoing one, and that you have to leave for the synthesis report. But really, thanks a lot for your contribution, Diana.
Thank you
and
for
we
the
are looking forward to see you again sometime soon. Okay, and with this, I think we can turn to the second presentation, which will be given by Michael Grubb, professor at the University College London. So we are really honored that you managed to come here, Michael, for this workshop. You are actually a regular presenter at REC, so really thank you very much for having you here for these meetings and events. What you have to know about Michael is that you are really active in all this climate-related work and the mitigation part. Since 2018, you are appointed as the convening lead author for Chapter 1 on the IPCC assessment report on the mitigation part. So that's where you will focus now your presentation. But what you have to know that you have a really nice curriculum. So you worked for Ofgem for many years as a senior advisor on sustainable energy policy, but later on all the improving regulatory field. You know really the regulatory part of the energy sector, which is a really good thing. And before joining the UCLI, you were actually part-time professor at the Cambridge University as well, and the research associate there. So it's really important to know. You were chief economist at the Carbon Trust, if I remember well, and you had 10 years at the Chatham House as well, where you were leading the energy and environmental program. So with this background and with this very wide viewpoint what you have, we are really looking forward to your presentation, which will be actually framing and we give the focus points of the climate mitigation part of the IPCC reports and IPCC works. And really thank you very much for accepting the invitation, and we are looking for your presentation. The floor is yours, Michael.
Okay, thank you very much. Can I check now? I've just called up my slides. Can you see that?
I see the slide. Can you go to the second page, because it's the uniform first page, I think, and from that can you go to the second slide?
Yeah.
Yeah, it works. You see it full screen. Thanks a lot.
That's great. Thank you very much. Thanks for your kind words, and congratulations also on your long sustained work at REC in Hungary. It's great. It's nice to be back. So yeah, Diana's given a great introduction, and I know I'm followed by Goran, who is the real energy expert and author on the energy chapter. So I'm going to give a broader overview focused on the mitigation report, but with some observations, if you like, about how to interpret the outcome and process. Just a quick reminder here of the sheer scale of this effort, which is rather daunting, and with the range of participation of countries, etc., and the sheer work of going through not only 60,000 review comments along the way, but having to document how we respond to every one of them. So this is not a trivial effort. The result, almost 3 years later, is a volume of actually well over 2,000 pages. So I'm not sure anybody would read it from front to end. And you could argue even the summaries, you could question whether a summary should be quite so long. But that does reflect the explosion of analysis and the range of issues that had to be covered. Now, obviously, none of us can cover all of that. What I will try and do, following on from Diana's context on the wider IPCC process and her highlighting some of the demand side and sectoral issues, is I'll say a little bit about introduction and framing almost on it. An important aspect of that emerged was around signs of progress and continuing challenges, including looking at various economic dimensions and the opportunities also that arise. So first, the bad news, but you kind of know all this. Global emissions have continued to rise. You can see there the contribution of the different gases compared in the standard way. Note the red methane in the context of 1.5 or 2. That is actually disproportionately important relative to the size here, which looks at the average impact over 100 years. Clearly, we're not on track to limit warming to 1.5. But from this also, I think it's worth and interesting to note that even the most basic scientific numbers have an element of how do you present them. So sorry, I'm just trying to check. Can you still see the slides? Okay.
Yes, we see it.
Fine. So I'm getting partially blocked. I need to slightly small. Okay. Suspect. Fine.
We see it popping up a window, but it disappears. So we see the slide of yours.
You see the slide. Fine.
Yeah.
Okay. That's the main thing. You've seen enough of me. So the basic data we know, and the increase in absolute terms over the last decade is also the largest ever seen. Now, we've known this is a problem for at least 3 decades, officially acknowledged, and scientifically for longer. So that's pretty depressing. On the other hand, the rate of growth has slowed significantly, and that also looks very interesting when you look at sectoral trends. And also, one can look at the more recent trends. The boom of Chinese emissions continued through to about 2013. Since then, actually, the rate of global emissions growth has slowed, and it has been over those 7-8 years roughly the same time, the same as global population growth. So per capita emissions, you could say, have stabilized, maybe. But we really wanted to look at a full decade in terms of IPCC. It's in our chapter that we look at some of the interim, more recent trends. Obviously, more caveats. The shorter the period, the less you can read into it. But if even a basic scientific question of how do we present trends in that way is complex, you can imagine the complexity in an intergovernmental context as to how we present regional data and trends. This is what we ended up with. There was a long history of discussion about how to present data by region. Countries don't like to be named individually in the IPCC process. We ended up with these 10 regions as the major framework of how we looked at trends internationally. And you can see there, obviously, the scale of growth from Eastern Asia, and the others as stacked up there in terms of their contribution of 2019. If we look at sectors, I won't show you the data in view of time. That itself gets complex, partly because of whether you allocate electricity to end use. Land use changes are still very annoyingly uncertain. We're not even 100% sure about the trend of land use change and forestry emissions. That's the horrible acronym, LULUCF. We can also look at it, and we do look at it across urban systems, which undoubtedly are a major driver. There's a whole section, particularly in the technical summary, that goes into more depth about the sectoral trends. And as to how we talk about the overall regional contributions, obviously there are various metrics one can consider. This one of the trends, I will show a little more, having, I guess, partly been involved in some of this. There was, not surprisingly, strong interest from many of the developing countries to have a look at the deep historical emissions. So on the left is the historical contributions of for fossil fuel CO2 and land use, best estimates, by those regions. And doesn't include methane for some fairly obvious reasons. Methane emitted 150 years ago is not of any relevance scientifically. On the right-hand side, again, distributional information, but this time in terms of vertically per capita emissions with each gas, plotted against the population horizontally. Some of you may have seen this kind of chart before. It takes a while to digest, but it's very informative. Look at, just how unequally emissions are distributed by various metrics, including actually within what one broadly called the developed countries, and I'll say a word about that. Just one other point about this, which is we do include some information on other metrics, emissions intensity, and also quite interesting, much better data and estimates these days of consumption footprints to try and address the question whether some of the reductions seen in developed countries are driven by outsourcing of emissions elsewhere. And the implication, if you look on that kind of consumption or footprint basis, is it does underline the inequality in emissions between different regions, but it doesn't fundamentally change the stories in terms of where trends in different regions are going if you look at it on a consumption basis. So one other point drawn in this case from the introductory chapter, or the framing chapter, is almost, it sounds silly, but how do we think about this problem? So we actually do draw upon quotes from the literature to illustrate what we call four analytic frameworks. Starting with the biggest market failure in history, which is how Lord Nicholas Stern described climate change. But there's also a book called The Perfect Moral Storm, which underlines that it is a very fundamental ethical challenge about how we think about our responsibilities, not just within our own societies, and globally, and future generations, and historical versus present or potential future contributions, rich versus poor, etc. Social scientists have, for a decade or more, been calling it a super wicked problem, which in this context means it is really difficult to solve because of all these complexities. And then there's a growing literature about the psychology and also the politics of climate change. Psychology that human beings were never really designed to think and act on this scale, which is what makes it such a tough challenge, and relatively open to political interference. So we use those terms really to say we need to think about this issue in multiple ways at the same time. We need to think about the economic dimension of aggregate efficiency. We need to think about the ethics and equity in a more disaggregated way. We need to think about innovation and transition dynamics, which is a more complex process of how our systems can change. And we need to think about the psychology and the politics that often get in the way, even when there is scientific and economic clarity about what needs to be done. So if I move on to the next stage, this is one of the headlines. Diana has fleshed this out very well. It's I think an intelligent way of avoiding what is a non-IPCC question about whether we can stay below 1.5. It's clear the greater the change, the more the risks and damages. But the numbers were effectively captured in this chart. So what this chart shows is the analysis of global emission trends for implementing policies, given current policies. The grey indicates the impact of the nationally determined contributions to 2030. The green is, you might say, the estimated least cost trend towards 2 degrees, and the blue towards 1.5 with limited overshoot. Diana also showed in some of the scenarios we're very likely to go a little bit above 1.5, whatever we do. But go on that blue trend, you're looking at reducing global emissions by about 43% by 2030, and major reductions in methane. Around 2 degrees, you can see the trend there, the data there, and in a nutshell, you could frame this as saying, if we're really serious about the Paris targets, the least cost way of getting there would be global emission reduction somewhere between 1/4 and almost 1/2, or 45% by 2030. And clearly, given what I showed you earlier about both trends and distributions, that's going to be very tough. I just want to stress one other aspect before I move on to another dimension of it. And this is not directly, sorry, on the left-hand side is text from the policymaker summary, which governments agreed. On the right-hand side is some of the supporting data. But it's really, on the right-hand side, it's a more extensive version of per capita information, in which the different regions, in this case 20 different regions, are plotted for their per capita emissions against Human Development Index, which is the horizontal here, which is an amalgamation of GDP, longevity, education levels. And one thing it shows is not only are historical trends unsustainable, but there are large variations in emissions between countries at similar levels of development. And all countries face challenges in future development, but they vary substantially. In particular, the countries towards the left-hand side at lower HDI levels are still in a process of meeting more basic human needs. And it's very clear that they're only going to get on a low emissions trajectory into what we call sustainable development corridor by enhancing a whole range of welfare improvements, many of which historically have involved more fossil fuels. And so there's a whole literature and discussion in the IPCC about shifting development pathways towards sustainability for both rich and poor regions. Won't dwell on that. You can read all the text, but it was really quite an important discussion, particularly for some of the developing countries, about whether and how far climate mitigation was synergistic or involved trade-offs with other development goals. And I'll return to that very briefly. So another area I wanted to quickly run through against fairly depressing backdrop is signs of progress. And there was a long debate about some of the implications of this. But first, unequivocally, the cost of renewable energy as a mainstay of low carbon solutions has come down dramatically. And we present in the SPM 5 different technology trends where that's true. And the agreed wording is more nuanced because it does vary by region, but it's fundamentally a breakthrough that supports what Diana said, that in many regions of the world, in reality, renewable energy is now cheaper than fossil fuels for electricity generation. The growth in those technologies has been exponential, as indicated here, both wind and solar now in the region of 700 gigawatts installed globally. Growth rates are for solar on the order of 30%, for electric vehicles even faster. I suspect most of this audience is very well capable of going to a spreadsheet and reminding themselves that our brains are not only hardwired to not think about climate change, they're not very good at exponential growth. So it's worth doing the maths and seeing how much changes how soon, if anything like those rates are sustained. You'll see rather more about the data on technology in the technical summary. Policy trends and impacts. It's another new area, and this really underlines, together with the previous one, a very important change of emphasis between this and previous assessments. Previous assessments were much more about the modelling, the projections, the what needed to be done. In this assessment, we were much more able to say, well, what has been done? What have been the successes, the limitations, etc.? Where is reality going on this issue? As I said, at a global level, global emissions, that looks pretty bad. Underneath that hood, it's much more interesting. On the left-hand side, lots of policy trends, about 20% global emissions covered by some form of carbon pricing, The Economists, direct climate laws in 56 countries covering more than half of emissions. It is sectorally still a bit patchy, much more coverage of energy than agriculture or in basic industry. Financial flows have increased significantly, but are uneven in all kinds of ways and have slowed more recently. In terms of policy impact, no question, policies have enhanced energy efficiency, reduced rates of deforestation, and accelerated technology deployment and cost reductions. At least 18 countries have sustained production-based greenhouse gas and consumption-based CO2 emissions for longer than 10 years. You'll find a couple of references actually in the SPM, one of which is in the context of Kyoto. One of the more interesting things about 9 o'clock on the Sunday night of final adoption. No, sorry, I'm mixing it up. 5 o'clock in the morning, I was asked to come back online and explain how many of those countries were East European. Obviously, countries worried about whether this was measuring the economies in transition reductions. And I was able to say that it was data since 2005, and the two economies of transition were Hungary and Romania. So there you go. It's interesting, and that's just a sample. The actual number is rather larger depending upon exactly how you measure and how you define the constraints. So significant countries have made progress, sustained emission reductions. Put all those together, and our best estimate of the impact of policies is somewhere between 1.8 and 5.9 gigatons of emission reductions annually already. And in fact, probably, well, we can discuss that. Surprisingly little literature, limited literature doing that kind of analysis. More broadly, some of those increases were arguably consistent in terms of rates for a 2-degree warning, but obviously only at national levels and for a few years. But then there's lots of other things going on. Zero emission targets by cities, regions, companies. It is a much broader effort going on in the world. So that really helped to inform what became very much a debate about glass half empty or half full, or more technically, in the technical summary, I think a great table on signs of progress and continuing challenges. I'm not going to elaborate on that further. You can have a look. Does that get us on a track to net zero, to the goals, temperature stabilization? Well, that does mean getting to net zero, no question, and roughly on the timescales that you can see there. Nobody would claim current policy efforts are yet on a track to net zero, but of course we are a pathway, and we can develop all kinds of future options, including some CDR. Just carbon dioxide removal to mop up the most difficult bits at the end. One other point about this is around the stranded assets and the carbon budgets. Don't want to go into too much detail. It was a major topic of discussion, and roughly speaking, the current infrastructure and that under construction, if operated to its expected lifetimes in expected patterns, would basically take us to 2 degrees. That's roughly how much carbon is baked into existing and planned infrastructure. For 1.5, therefore, there is a substantial stranded assets issue, or if that's the right term. Also noting, most of the remaining fossil fuel emissions occur outside the power sector, particularly industry and transport. Therefore, that implies strong action in the power sector rapidly to get the carbon dioxide out of it. And we run through what those various options may be. But more emphasis upon stranded assets is definitely a big thing. Now, the sectoral reports, the report is organized in the 6 sectors. Diana has run through those. I'm not going to repeat that. Goran can pick up the energy dimensions. But I thought I would finish really by touching a little bit on the costs and benefits at an aggregate level, and then some wrap-up comments. So one striking report figure in the SPM is, I find this one, it's a bottom-up technology engineering calculation of the costs of cutting emissions in 2030. And the significant thing, the most significant, is those 2 bars at the top, wind and solar as mentioned. The blue is options which were negotiated to describe as costs which are lower than the reference case, which is broadly the code word, as Diana said, for the fact these technologies are now cheaper than fossil fuels in many applications. And the overall potential, just up to maybe a cost level of $20 per ton, which is really very cheap, is at least 5 to 6 gigatons of emission reductions by 2030. And that is, that's a major contribution. There are many others, many more limited or potentially higher cost as flagged. You can imagine how controversial some of this was. Goran may say a little more. This chart does carry on through the other 5 sectors, the whole land use, agriculture, forestry, etc. The buildings, as Diana said, notably cheap options. And this is primarily the direct emission reductions at the end. And wide range of options in transport. Again, notable for how many of them look economically relatively attractive, which is not so much the case for industry as flagged by the cost columns. So there's a lot of data to pour on. The bottom line is that options up to $100 a ton could more or less halve global emissions by 2030. Now, all the economists here will know it ain't that simple because there are many obstacles, challenges, potentially hidden costs. But nevertheless, it's a cautiously positive story on the underlying economics. We flag there the options and acknowledge that what options work and what options are cheap will vary by region. A few words just on the macroeconomics without going into great detail. Actually, even thinking about it is quite hard. If you're saying what's the macroeconomics of climate change, what are the costs and benefits? The short answer is it's really complicated and inevitably controversial for reasons flagged on the left there. Even technically, there are a lot of economic debates, not resolved, still in contention, including at the bottom, the economics of innovation and transition. How we've made astonishing progress. The economics look radically different now than they did 10 years ago on a century-long problem. That tells us something about the capacity to change what we think the costs and benefits might be. And I didn't know how to summarize these paragraphs. They're arguably the longest in the SPM. I've added a little bit of bold to try and justify the 2 core statements that the aggregate GDP effects of mitigation are small and compared with projected GDP growth, and that overall, the majority, though not all, of cost-benefit studies conclude that just in pure cost-benefit terms, limiting warming to below 2 degrees absolutely makes sense, even before you consider some of the wider debates and risks. The macroeconomics touch on the finance, investment gaps. We have insufficient global capital. There is a chart which details both the current flows of low carbon investment, the blues on the left of this chart, and where we would need to be by 2030, over to 2030. And so there's a sizable gap in the finance overall. That's not new, but it's the first time it's been charted by region. This data appears in a technical summary mostly because of political discussions, not about the numbers, but about how to classify. A range of instruments, policy packages are needed, and those need to also stimulate technology and innovation through a multiple options. And also wrapped in the technology and innovation are the thorny issues around accelerating diffusion of the progress that has been made. And my sense is this is actually one of the under-researched and underappreciated, but absolutely central dimensions to think about. So I'm just going to finish with a reminder of a comment I made in the framing. Climate mitigation is only going to work in the real world if it is actually organized in ways which contribute to meeting other societal goals as well. And the SDGs are a very useful framework against which to consider those. More detail in the report and the SPM includes charts which look at where are the potential synergies across the different sectors, across the 6 sectors. Where can action on climate change actually help with some of these other goals as well as where are some of the trade-offs? And on balance, there are far more synergies than trade-offs that we find. But on that note, I've probably spoken for a bit too long, but then it is a massive report, as you'll gather. So I hope I've picked out some useful highlights. Thank you very much.
Thank you very much, Michael. Thank you very much for this really nice introduction. And you have the feeling after your presentation that maybe we cannot read the full document, but parts of it will have to be read by everyone, because very interesting charts you have with probably lots of questions from the audience. But we have to move on because we have the third presenter, Goran Strabak, waiting for his part. And actually, as Michael, you mentioned, Goran is a really expert in energy systems and energy system modeling and analysis. He's from the Imperial College of London with a very extensive experience in advanced modeling and operation, planning and security of energy systems, which is the topic of the third presentation. So we are really welcome you here, Goran. What I learned from the others that we might not be able to see Goran because there is an issue with his camera, but I hope we'll hear you. And what you have to do. Yeah, I hear you. So it's good.
Okay,
that,
thank you very much indeed. Apologies. I don't know, something is wrong with my laptop. So you know, I don't know what exactly is going on. These old ones, there are some problems. Apologies for this, but many thanks for this. And I will go through this issues regarding the energy system decarbonization. And already there is a significant amount of material which is already Daniela and Michael very well presented. Just to if we can, given the timing also, if we can go through these slides. And apologies, I just found out that it wasn't on the IPCC background, it's Imperial College background. I will send you the one which is changed. So sorry for this. We can go to the next slide, please.
Yes, okay.
Which you have already seen. Michael has presented this and explained very clearly that we would need to go with significant reduction in the fossil fuel. And you can see in here that, you know, the red one was the, you know, if we continue as we are now, business as usual, versus if we move to these areas with the, you know, reduction to meet the 2 degrees Celsius. 1.5 is the blue one in here, showing how much we would need to reduce the greenhouse gas emissions in the energy systems. So there will be massive change in the energy sector to provide that. But again, as kind of, you know, is being indicated already, is that it is, you know, at a kind of as we say, kind of engineers can do much bigger magic than making zero carbon energy systems. You know, we sent mankind to the moon 50 years ago. The question here, the core question is, how do we get there cost effectively? And that is what Michael and Diana have emphasized strongly. You can see that in here there is also this that we do kind of overshoot at the very beginning, which is the kind of the blue one, middle one, so that then you would then need to reduce further on later on. But you can see that 1.5 is a very, very, is going to change massively the emissions. So if we go to the next one, please. This is just to highlight the key questions which chapter 6 was addressing as to how how we can move to this small or zero carbon energy system going forward. And currently, it says in the future that all electricity will need to be produced by by low carbon or zero carbon energy systems such as renewables, which is solar, wind, nuclear. There is also bioenergy, hydropower, geothermal, but also there is also significant interest in deployment of carbon capture and storage. And there is now quite a big development in these areas on technology side as well. And that also could provide, again, some of these aspects in terms of cost-effective transition. It may play a major role, although, as Michael Hartwig will show that as well, is that there was a significant reduction in costs of renewable generation in particular, which is also playing a major role in here. Also, what we said in here that we need to replace fossil fuel. This is to do with the also on the end use side, which is transport, heating, cooling industry, and that's where the electricity, hydrogen, and bioenergy, are going to play a major role. Then also, I think Diana has mentioned also that we are also moving to the world. We are going to be able to reduce demand by increasing the efficiency and use less energy, and have also, the technology, reduction such as insulation levels, but also, you may know that the lighting now is consuming, less than 5 times more energy for the same lighting produced. Also appliances, and this is where the also the public low carbon transportation is going to play a major role as well. So just summary the change that we would need to reduce significantly use of fossil fuel. That's the kind of core aspects and moving to this new generation. So that this is also, there are massive challenges in terms of technology developments and systems, and it is important that we start moving to this sooner rather than later to make sure that we can meet these targets in time, and also to try to understand where the challenges are associated with the new technologies, and in particular one of the aspects is to do with the hydrogen production, because that's going to play a major role, and there are still a bit of uncertainties and the challenges on technology side to make that work. And also there is, as Michael indicated, there is also significant now developments in new policies regarding the transition to low carbon future, and that's also where also Diana mentioned there will be also kind of that we also need to change potentially kind of how we live, how we behave going forward to actually meet those targets. So the next one is just showing the change in the energy system which will be required, and you can see in here, this is just on the top side, on the right hand side is the this is just kind of the coal-fired generation, and we've got you can see in here that there is a quite significant amount in some of the parts of the world. This is China, India, and so forth. And we would one of the core aspects is that we would need to phase out the coal in the next few decades. This is just at the bottom showing that if we go to how fast this is going to happen. You can see light gray is kind of 50 years, but also there is significant need to, if we are to meet the 1.5 or 2 degrees, we would need to start doing this immediately. And you can see that, by kind of, 2030, if we go to 1.5, without over that, this would need to be achieved. So there is a very significant change in the sector. We just need to bear in mind as well that some of these technologies can last for a very long time, but also there is also the development of the carbon capture and storage, which also can help potentially with this phasing out of the coal. So the next one is just showing the technology development. And as Michael mentioned, renewable energy, the costs have reduced massively. You can see that from in the last 5 years there was more than 50% reduction in costs in solar and wind generation, which is obviously massively relevant. You can see on the right hand side showing that there is increase in load factors, although these are kind of the actual load factors. But now on the green side, the capacity factors for offshore wind are now bigger than this. Kind of they are reaching 60%, and you can see that the costs is more than halved. Levelized cost of electricity. There is also kind of on the bottom is offshore wind written, but again this is kind of going up and down. But this is just depending on years. But overall, the load factors of offshore wind is also massively increased. You can see that that fundamentally leads to very significant reduction in levelized cost, which is about more than 50%, and that is going to enable very cost-effective transition to the low carbon energy system. And also you can see in here we've got a global kind of diagram from the chapter that there is a very significant increase in sorry, what is now this? Somebody is calling me. Let me just try to stop that. They're showing that there is an increase, but it's still, in the last several years, but it's still relatively overall, it is small proportion, but there is a significant, interest now in moving this forward with solar and wind, which is going to play a major role in supporting this energy decarbonization. If you go to the next one, just a little bit about which is being already a bit highlighted, but this is in our section to do with these scenarios which we analyzed, and it says in the bottom, it's not very easy to see, but you can see there is 1.5 degrees, but without overshoot, which means we want to make that happen properly. And then we also got with overshoot, but we also got then 2 degrees and with delays and without delays, and just showing how this would work. And you can see that in some of these, for example, that in the bioenergy, that we would although if we do with the overshoot now, we would then need to increase deployment much more later on, and the same applies to the carbon capture and storage systems. This is just again different scenarios as to how this decarbonization and the use of these different technologies will potentially vary depending on in timescales. But it's just showing in broad terms that all of these low carbon energy production technologies are increasing going forward. And also we would need to, if we've got delays now, we would then need to increase this going forward. If you go to the next one, showing the this is to do with the demand side, that we are going to have again with these scenarios, showing that we would have transport, for example, obviously increasing, because there is a significant electrification of transport sector and also hydrogen on that front, and also the industrial sector, residential, commercial, which is Diana has mentioned that, so that we would need to, there will be significant changes also at the end of the of energy demand, so that the energy sector also is also critically important to have this production and demand in the low carbon agenda. And this is what is just showing at a high level where we are, and also in some of these, for example, in the hydrogen production, for example, industry, if we don't if we don't do this now immediately, we would then need to increase significantly. If we do without overshoot, and with overshoot, we would need to increase that then going forward. So if we go to the next one, please. So this is regarding renewables, because they're going to play a major role. And the question, there was a discussion significant about, whether the renewables will be able to provide full decarbonization from production side. And of course, there is differences in different countries, and there will be different energy resources being used, but also, this is also there is also nuclear and other fossil fuel energy with CO2 emissions, which are going to be CCS, we're going to do carbon capture storage, are going to play also a major role. But the core aspect is that it's mentioned that the costs have massively reduced, and that there is a very significant interest in terms of getting that forward. But what some of this analysis, and this is also still work going on in this area, are we able to have a kind of entirely renewable energy sources driven electricity system? And there are kind of on both sides, yes and no, but there is a significant potential role in here of renewables. But there is one of the core aspects of this is to do with the system integration. So if you go to the next slide, this is just to give you an example of the, for example, operation of the renewable energy dominated system. This is just an example in Europe in percentage terms. You can see on the right, on the x-axis is the time, so it's across the year on hourly basis. You can see how there is a significant variability in wind production, and one of the core challenges in here is how we're going to make the balance of demand and supply given this very big variability. And that is one of the also important sections which in our chapter regarding the overall system integration, which is on the next slide highlighted. So there are these two kind of pictures in there on the left hand side showing that that we could use flexible technologies, such as there are developments, significant developments in network technologies, demand response, energy storage, which are going to play a major role to support this transition. And also we are also moving to digitalized world, which is critically important to shift the historical approach of delivering security supply from redundancy in assets to actually smart control. And this is also savings, massive savings in the infrastructure to make that work. And also on the right hand side is also what is also demonstrated very strongly, and also there are a number of applications in this area, that we need to have interaction between different energy sectors rather than look at them in isolation, because there is showing that there will be flexibility, for example, in heat sector to support electricity system and so forth. So it is critically important that we do that in integrated fashion. And also there is also very significant importance of balancing the conflict synergies between local, district, regional, national, and international scale. And that is also because of the resources in particular, that we need to look at the district level, kind of street level infrastructure, but also national, international level infrastructure is also critically important. An example would be kind of offshore wind. There is a huge amount of growth, so we also need to look at that in a more global perspective. But also there is also big development at the local infrastructure level, and where is the balance between these is one of the big challenges regarding this energy system decarbonization, to get the whole systems approach in here, in kind of spatial, temporal, but also to look at these different energy sectors, so we can link thermal energy, transport, building, and so forth, electricity, and so forth. So and that provides significant benefits in terms of cost-effective decarbonization. Now, if we go to the next one, this is showing that the hydrogen has got a potentially major role to play in supporting this cost-effective transition. And this is just to say there is now massive interest and there is strong developments in production of hydrogen. You can see in here there is producing hydrogen by renewables through various electrolyzers, which is now there is significant activities in this area, demonstrations. But there is also to use, for example, to use autothermal reformers to make hydrogen from gas or biogas and then use the carbon capture and storage to make that work. There is also significant challenges associated with transport of hydrogen, given that it's got a very small energy density, and there is big developments regarding how we can enhance that to make sure that we can use these different transport technologies. You can see in here, this is there is liquefied or also using gas infrastructure or using ships and so forth, and that's quite a big activity in this area. And then also at the end use of hydrogen is also a big development in terms of in addition to having storage. There is also kind of more on the utilization. There is also how the industry sector would change and to do that, but also the long distance transport sector such as aviation or buses or trains could potentially use that. And also there is also interest in using a gas plant, but actually which will be using hydrogen. And there is also very significant developments now in this area to make that utilization of hydrogen more cost effective. And now, if we go to the next one, is just to say that there is a very now strong interest in discussions about having kind of net zero energy system, which is a big activity. This is just showing that the electricity system, we can remove CO2 from these sources. There is also, as I mentioned already, greater interest in energy system integration and also looking into the regions and also different sectors, which is also critically important. And also there is a significant interest in increasing electrification because of these rather than using fossil fuel. That is where the fossil fuel would need to be reduced, and that's where the electricity system can help. And also there is a growing alternative energy carriers such as hydrogen, bioenergy, which are also getting very big on the agenda on the energy system. And also, as mentioned also by Diana and Michael, also this energy efficiency is critically important, but there is also very big developments in the area of direct air carbon capture and also bioenergy carbon capture storage to offset the residual emissions, which is also getting big in the development. Now, if we go to the next slide, it's just a kind of high level summary. You can see in here that we have different energy sectors in here. We've got the top, the purple one is the kind of, you can see carbon, hydrogen, oxygen, various aspects of it. Then we also have the ammonia. We got hydrogen at the bottom, electricity, and these are all linked. And having this coordinated approach to supporting this transition is of critical importance. And this is one of also the core aspects of what the messages of what the our chapter 6 is showing. And the last slide is just to illustrate that how these emissions are going to change. In here, where we need to have these emissions, you can see that we've got from agriculture and end use, we want to move into the negative emissions, but there would be also residual emissions in some of the industrial sector. And this is what we also need to, the idea is also different approaches to have also negative emissions from the sector. And this is also showing how these different emissions, including you can see in here greenhouse gas, also CO2, but also the methane is also included, and how against these different scenarios we would need to reduce these emissions, and the energy sector is the core to make that work. Yeah, this is the last one is just what you've seen already is summary. So that is where I am, and many thanks for the invite. Sorry that I'll try to send you slightly updated presentation, and much appreciate presentations by Diana and Michael, which were very, very critically important in this context. Thank you very much, colleagues.
Thank you very much, Goran. And just a question, if you can stay a bit more, or you have to leave now already for another meeting. Will you have some time to stay for the panel discussion?
Yeah, I would need to go, but I will try to stay on and see if I can take part. But they are pressing me to go to this other meeting, which is started. But I can potentially.
But thank you very much for your presentation.
Yeah, but please keep me on. I will try to be present.
Okay, and I would like to invite Gabriela, my colleague, Gabriela Salku, who will lead the panel discussion. We are in a bit delay, but I think there can be some important questions which we can still cover.
Yeah.
So the floor will be yours, and we are looking also at the chat box. So if you have questions from the audience, please send it there, and we are following that one.
Exactly. Thank you very much for staying on, and I'm happy to see Diana back. Let me ask the audience if you have questions to the latest presentation, because Goran is still here, but he might leave soon. So any questions to the energy systems part, which is probably the core interest to our workshop audience.
I think, Gabriela, they can only write the questions. We cannot hear the audio, but I will look at if they type something.
Thank you. Until then, I'm not sure if Goran is still here, but I would have a question. It seems to me that the issue of nuclear power staying with us was not explicitly touched upon in your presentation. What is your expert opinion on that? Are we needing new nuclear base load plants to make it to the net zero transition?
Yeah, on that context, there is a need for, which I should have probably emphasized a bit more strongly, there is a need for firm low carbon generation. We cannot only work with renewables, and it will be cost effective to have, again, the nuclear is potentially going to play a visible role in here, but there is also development in other firm low carbon generation technologies, such as, for example, producing, although this is more expensive, producing, for example, hydrogen from renewables, and then
we seem to have lost Goran's voice.
Yeah, I don't hear him neither. Let's hope that he will be able to come back. And then maybe just one more information to you, Gabi, that Diana managed to come back, but she has limited time to stay with us. So if you have questions to Diana, maybe this is the time as well.
Okay, until Goran's back, I'd like the other two participants of the panel to touch upon the nuclear issue, because since we are in Hungary, we know that this is now a very open question. We were having plans to reschedule the renewal of our nuclear power plant, and this seems to be now an open question again. And I'd like to hear Michael's and Diana's comments on that. What are the trends relating to old-fashioned nuclear power plants? Are they out of the portfolio in other countries, or are they coming back elsewhere?
I don't know if Diana wants to make any comment from an IPCC perspective. It was obviously a lively issue.
Go ahead, Michael. Let's go first.
Okay. Look, I think this is an area where national perspectives differ widely, and to be fair, views amongst researchers, including amongst IPCC authors, differ quite widely. And as we know, it's very diverse even within Europe. Since you asked the broader question, I mean, in a sense, the depth of feelings and divergences slightly muted what the IPCC could say about nuclear. Goran's touched upon it. Just two comments from myself. One is that we, I think, do see, under particularly the impact of the current energy crisis, some resurgence of discussions about nuclear power. But of course, that can only lead to actions that deliver installed nuclear power stations long after this energy crisis has passed. So it's it's more of a political phenomena that maybe has reinstated debate in some countries. But then the other, and that includes the UK, where the government has announced in principle plans for nuclear power, for a new fleet of nuclear power stations out to 2050 that would projected to provide 20%. But to be honest, as one of my colleagues remarked, it's funny how every few years the government announces a major nuclear power program, and we've had this for at least 20 or 30 years. And, you know, if we're lucky, we end up with one after about 15 or 20 years after the government promised a family. Two remarks, technical remarks on it though. One is, and there I will touch on the IPCC. For the first time, the IPCC discussed not just the trends in technology costs, but the characteristics of the trends in technology costs. What kind of technology costs, not kind of technologies, have we seen major cost reductions? And what do we know about why we see it in some areas and not in others? And the answer is sort of not rocket science, but nevertheless, it's much clearer in the literature. There are reasons why we have seen big reductions in renewable energy costs. They're small, they're modular, you can do rapid cycles of learning and improvement, you get economies of scale in production, in manufacturing, supply chain, and all of those things. For the really big complicated kits, like nuclear power stations or like CCS, progress has actually been very disappointing. And that's partly because there is so much less opportunity to build scale, to learn quickly. Can't really set up a manufacturing line which just reproduces the same thing to be applied globally. So I think many did emerge as quite pessimistic about the prospects for major cost reductions. Goran indicated, obviously the debate is around baseload nuclear, but also actually the biggest new question about nuclear power is, in many countries, including Europe, if we build any new nuclear, it's going to have to be flexible nuclear, which can cycle up and down according to the variations in renewables. And that will further complicate the economics of it. Technically, we know it can be done. French nuclear does that. But of course, it makes it economically less attractive. And it doesn't make sense to build nuclear if it's simply going to throw renewables off the system.
Thank you, Mike. Any comments on that?
I think Michael has really excellent summary. Maybe just a couple of points. Yes, indeed, it's always a very controversial topic in IPCC, and if Goran were online, it would be really interesting to hear his perspective from how it panned out in the energy chapter. What I have seen is how it panned out in the summary for policymakers, and every time we had a big debate on this among governments and what to include and what not to include. Very surprisingly this time, there was absolutely no discussion from the governments on nuclear. And if you notice, there is no word on nuclear in our summary for policymakers. That was also a surprise to us, actually. I mean, not us governments. Of course, from the author's perspective, it was easier for us to avoid this topic because it is so controversial than push it. But we expected that we had back pocket text to have, but the governments did not ask for it. That was actually quite surprising. The back pocket text that we had about that, and if we were asked to put it into summary for policymakers, that was agreed among all the experts as well, because as Michael said, this is there are different perspectives. But what the facts show is that nuclear is what was the word which was, I'm trying to remember the exact terminology that was used, that it's maybe I won't remember the exact word, but basically it is an established technology that has been used for a long time, and it's mature. Yes, I remember. It's a mature technology, established technology that has been used for a long time, and it's an important source of baseload power, as Michael mentioned. What we do have I think in the SPM is what Michael says is about the costs, that whereas some system costs have very significantly reduced, you do not see the cost reduction in other systems such as nuclear, because the scale really matters again, as Michael pointed out very well. The small case systems are usually the ones which see the biggest improvement both in technology and in cost, and they seem to be more palatable with more the IT development as well, and smart systems and smart societies, whether that's not true for these large-scale systems like nuclear. The other point is that the development in small scale, so modular reactors. So there is technology development, and there's some promise in small scale, more modular reactors, and that may be more promising. But right now, the technology is not yet there that the experts would have seen it as a promising opportunity to put on the table as one of the portfolios. And not from the IPCC, but an interesting thing is that I don't know if you know Nebojša Nakicenovic. He's he was also a very key figure in whole scenarios, IPCC scenarios and IPCC, and he was the leader of the global energy assessment, World Energy Assessment and the Global Energy Assessment. Now he's actually the Chief Scientific Advisor of the European Commission. And we had a session, because I'm also on the waiting list for this position, and we had a session in Glasgow actually with Chief Scientific Advisors. And this was the same question came, and since I worked with him, I know that he's actually very much supporting, very much pro-nuclear person. And what his answer was to this question is, it's simply too expensive. This is simply the most expensive form of energy that we have today. Nevertheless, I think what the answer is, what basically Mike said, that for base load, in a decarbonized electricity system, we may not have for a while until the systems are more able to provide with fully intermittent electricity supplies, very full solutions. Until then, it may play a very important role in the base load under the conditions, as Michael said. So this is what I would be able to add. And now I really have to leave. I apologize. Thank you for the invitation again.
Thanks for coming back. It was great having you, and good work for you in Dublin.
Thanks, Diana. Best of luck.
Yeah, it was good to see you, Michael. Thanks for the great work.
We have a couple of more minutes to go, and since I cannot see new questions flowing into the stream, let me have another one to Michael. For me, it was striking to see that the whole report seems to have an impression that the science is there, it's unquestionable. And also, at least to the energy systems regard, the technology is there. Most of the technology is hitting the markets without support, or it is very close to it has already demonstrated its industrial scale viability and so forth. What we seem to lack now is the innovation from the policymakers and the political marketing of how to sell the whole story to voters, to the citizens. Do you have any feedback from colleagues if there is something happening in that respect?
That's a great question. First, let me just slightly caveat your first part. I mean, in a sense, the nature of academics, scientists will always question the science, but I mean, in terms of the physical science, you know, just the data and theories are unambiguous. It's a bit like still trying to debate whether the Earth is round. There's still lots that we don't understand about exactly how some of climate change will play out over the century or more. In the economics and technology, I think the specialists are increasingly confident about the electricity system. At least, you know, the broad opportunities and the potential for major changes over the next decade or two in electricity. There was certainly debate, and Goran covered it very well, about how credible are 100% renewable electricity systems, and I think most of us would say, well, that's not in itself a key question. We know we can do a lot more with renewables. We know the capacity to deal with intermittency is much bigger than many people thought. That doesn't mean it will be 100%. It doesn't mean we don't need other things, of course. I think the biggest caveats are around some of the other sectors. So transport, land transport, looks like we know the options, and we have the options broadly, and we can see the cost reductions. That is much less true for major shipping or aviation, or indeed some heavy goods. But some of those we suspect we can see a pathway. Buildings, Diana covered well. Clearly major implementation and management challenges, but mostly not fundamental technical challenges, although I have to say, coming from Britain with a lot of established, very bad infrastructure, we still have major challenges in decarbonising heating. Then there are some bits of industry, a whole spectrum of industry, I think, ranging from some bits we really know, many bits we think we can see our way, such as steel, hydrogen-based steel, electrification of quite a lot of chemical processes. Some, like cement, still a lot of debate around what are the options, and maybe alternative materials. So, you know, it's not a blanket. The science is clear, the technology is clear, and the only problem is politics. It's the science is clear, technology has made huge advances. We can see answers mostly in the power sector and surface transport, and then a sort of a tail of some of the more thorny bits. But your point, yeah, I think what really emerges is this is a problem about policy and governance, much more than technology and economics. And I think the research community as a whole has frankly been rather slow to get to grips with that. I think because so much of the energy and climate area has been, you know, pretty technocratic in its analysis. And there has been a lot of technology assessment, engineering cost estimates, technical modeling, and there was still this debate. Now the global models have kind of turned on their head from 10 or 20 years ago to say, yeah, immediate deep cost reductions make economic sense. That then raises the question of, well, they might make sense in your model, but you really think that's going to happen? And what would it really take? And that's why we pushed this issue about the 4 frameworks. the literature is still dominated by the first framework, broadly engineering and economics and modeling. There is a separate literature on ethics and equity, which is, however, seen as extremely important in most countries. There's a really emergent literature on innovation and transition dynamics, which is another lens on the whole thing. And there's a very thin literature on politics, which was hard to discuss in the IPCC, but is obviously really important when you look in particular at what's happened in America and why, and some other regions.
Yeah, it's heartening to understand there are advances, but you know, in a country where you can win parliamentary elections by stating that utility bills will not be changed ever, it's not very heartening from this end of the spectrum. Let's see, are we having questions from the audience? I cannot see.
I see new questions coming from the audience, actually.
Then probably I'm closing this one person.
We had one
panel.
question.
Someone,
Yes,
go ahead.
please.
It's me, Katalin, but I saw a question. I sent it to you, Gabriela.
I cannot see it. I'm sorry. Can you read it up?
Yes, just a second.
I don't see it. Sorry.
I don't see it either.
It disappeared.
While you're hunting for that, let me make one reaction also to your comment just now, Gabriela. I presume you're referring to a recent local election, a recent election in Central Europe. The really interesting thing is the only way we can now contain the impact on consumer energy bills in a sustainable way, in at least electricity, is through rapidly accelerating progress on renewable energy and giving consumers direct access to electricity at roughly that cost. Because the problem in the European energy system is the electricity price is being driven by gas, which makes no sense given what has now happened to relative prices. That's an area I'm fascinated and working on as a researcher right now, because I think it implies a much deeper level of reforming electricity regulation across Europe than currently the European Commission are willing to consider.
Yeah, that would take a whole new workshop to cover this aspect, but yeah, this is very decisive in our region.
Yeah.
I found the question. It came from Gerhard Nagel, and he asks, what about hydropower? Damming rivers is contrary to objectives in river water ecosystems and biodiversity. Nevertheless, it is still globally the major renewable energy source. So Gerhard asks about hydropower. Thank you for your question.
Okay, I heard that. Ideally, you'd want Goran, but in Goran's absence, I will try. I think broadly the consensus view is that in most of the developed world, hydropower has been exploited to fairly close to the sort of socially and ecologically acceptable maximum. There may be exceptions, and it's interesting to look regionally. I mean, the sheer amount of hydropower in Norway, for example, and I'm not sure that the European continent makes full use of that. But broadly, the debate about additional hydropower at scale is going to be in some of the emerging developing economies more. And even there, it does face limits of various sorts. It's not an area I'm an expert on. I'm not saying that there'd be no new hydropower. Even in Europe, I think there are some debates ongoing in parts. But in terms of the scale of what needs to be done, hydropower is going to be in most areas a supportive technology to help manage the intermittency rather than a mainstay of future expansion, would be my strong impression.
And maybe, Gabi, if you allow me one more connect.
Sure.
To the previous, because I know you have more questions, Gabriela, but you had a very interesting chart on the financing and on the macroeconomics, Marika, which meant that with these technologies, I think the investment cost has to be really scaled up. If that figure, which was there for 3-6 times more, if that referred to that one, I'm not sure because it was not clear from the slide itself. But my impression is that we really have to scale up investment, which means that we have to put a lot of money at the beginning of the process, because it's not the fuel which we spend, but on the technologies itself and the research and development. And then once we do it, there was an interesting additional issue which Diana mentioned, is that the upper class, I mean the richer part of society, has higher emission. But in my impression, this investment flow will come from those who can save. So savings would be needed to scale up, and there is usually a price for that. So I don't know if the inequality in these would further increase or not, and what is the role and what are the tools to keep the cost of these financing at a low level. So how do you see that if you work with the macroeconomic part of the equation?
Yeah. No, Laszlo, thank you for that. Again, very pertinent question. So on the surface, it looks a little bit like a paradox that we're saying there's a lot of stuff which is actually very cheap, but we need to massively scale up investment. Of course, it's not a paradox. Partly, as you say, because a lot of the new sources are capital intensive, they require the capital investment up front that would lead to a longer term stream of cheap energy. But also the data on the cost of renewables does depend strongly upon the cost of finance. I'm sure you're familiar, but the audience may be less familiar. We have had an extensive period of very cheap money, very low interest rates. That is one of the major factors that has helped renewable energy to become cheap. It looks like we are leaving the era of low interest rates. The price of everything is going to go up, including the cost of capital and therefore the cost of renewables, probably. It doesn't change the fundamental economics, but it does mean that the cost of capital gets to be a critical determinant. And what we've actually seen over the last two years or more or so is, by and large, people with money still trust the stable, developed countries as relatively low risk places, low cost of finance. But particularly in the aftermath of COVID, a lot of developing countries are even more debt ridden. There are fears about risks of credit defaults. So the country level risk is heightened, the cost of capital is heightened, and that impedes development, impedes investment of the scale we want. You're right, that it is a very strange world because governments have a lot less money post-COVID, but there are still vast pools of private capital, which is where the link comes in also with the very rich, very rich consumers, the Bezos and Elon Musk and many others, and the private capital markets. So a lot hinges on whether we can get smart policy that encourages more of that capital into clean energy globally. And that's one of the most important policy design questions. There are ideas afoot. We saw one example in the South African deal that was announced at COP26, where that was a homegrown initiative in South Africa about how could they get out of coal. South Africa is a very coal-dominated country, and they reached a political tentative consensus in South Africa, but it hinged upon having both some finance for the just transition of coal mining and for underwriting some of the risks of foreign investment in clean energy in South Africa. So that was a really interesting case study on what potentially could be done given the right sort of political environment, both domestically and internationally, to support it. You know, not easy to replicate that everywhere.
It is very interesting. We you know, we work at the university, which is basically an economics school, and we teach students, and we have loads of classes about how policy should correct such market failures, and we talk about carbon taxes all the time in climate economics relations, and now we are very disappointed to see how reluctant governments are to put carbon taxes in place or to scale up carbon taxes to the right magnitude. But now it seems to me, and I'd like your opinion on that, it seems to me that carbon tax will never be the tool that would deliver the solution.
Well, I wouldn't say never, well, except that you said will be the tool that delivers the solution. I think Laszlo may know, a while ago, I wrote a book, partly because I was so frustrated and partly trying to understand what we'd learned. One of the main themes of that book was that actually there are multiple things that need doing and multiple instruments that need to be brought to bear. And I framed that in terms of three main pillars of policy. And getting prices right and markets to operate was one of those three pillars, but it's not the only one. And I think part of the problem is we have taught too many economists that carbon pricing is the answer and everything else is less efficient. Whereas actually, I think it's much more carbon pricing, because of its major distributional impacts, is going to have to co-evolve along with enhanced efficiency and innovation, which makes it cheap and easy for people to escape the impact of carbon pricing by moving to lower carbon solutions. So I very much see it as a sort of co-evolution of the three pillars of policy. And I mean, just closest to home, and we'd need to finish here. Sorry, I will need to go. Closest to home in the UK, although we talk about the UK carbon floor price as having driven coal out of the system, that's kind of true, but it's only because we also had a period of enhanced efficiency and a rapid growth of renewable energy, which meant that actually we no longer needed coal, given other things that had been driven by other instruments. So yeah, and the IPCC, very much the language is all about policy packages. So.
Yeah, thank you very much, Michael, for this very powerful message at the end of our workshop. And thank you for being here and taking all this time.
That's all right. Thank you very much for the invitation. And nice to see you again. It's been interesting.
Great hearing you again. Thank you.
Thank you.
Thank you for all the participants. We are sharing the link to the recording on our website. Great. Bye-bye.
Bye-bye.
Ciao.
Thank you very much from my side as well. Thank you. Bye-bye.